One, two, three. Hello. Okay, looks like it's working now. Maybe. I am not sure. Um, but so I'm going to continue what I was trying to do the other day. Unfortunately, um, the stream wasn't set up properly, so it was very choppy. But I am basically adding features to a new library of mine, which is OP-AWS LC. And we were adding RSA support to the library. So we're going to keep doing that. Um, just let me think where we left. We left at adding support for encryption, and we got an array buffer. So now we need to add support for decryption. And for encryption, we were at we separated our functions. One was the encrypt with RSA key. So one was generating the key, and the other one was the actual encryption. So we first generate the key to get the length, the maximum length of this function. And then we actually encrypt it. For good. So what we need to do now is we need to create the decryption function, and just let me take a look. So we have our ciphertext, which will be the array buffer. Wait. I'm sending too much data to YouTube now. So still wrong. Change that. Maybe we'll be happy now. Good. So we need to generate an OAP private decryption key, and from that key we get the minimum output size. And this was one of the questions I had last time. Why should it be the minimum size instead of, how can I share this video? Here. we have we create a private key, an RSA OE, no, OAEP, and um, the plain text is the minimum output size of RSA. Build snippet of dots. Let's use. Uh, I don't understand why I use name output size. What if the original cipher text, not the original plain text was longer? The maximum possible plain text size that could be encrypted into a ciphertext of there is a key size. The actual decrypt might be smaller than this buffer. Has a maximum plain text size. You can encrypt that longer. Never heard. When decrypt returns slide, discarding the output buffer. It's actually the minimum output size returns the maximum possible plain text size that could be encrypted into a ciphertext. But here it says minimum. Why? Buffer size. Return the for self.decrypt. The actual decrypted plain text might be smaller than this buffer, which is why the decrypt function returns a slice of the actual output. Am I understanding something wrong here? Like, am I missing something? Oh, why is this return? Oh, okay. This is just for intermediate decryption, I guess, and this is returning the actual. Hmm. Because where's decrypt? Um, decrypt. Well, let's just implement it and see how far we get. So maybe we can do this in one go. No, mango public function unsafe extend c RSA OEAP decrypt. We need private key and um, we will need the private key handle. What else do we need? We need the algorithm and we need our ciphertext. Did I already find this? must be defined. Let's say decrypt. Ah, ah, oops, already did this. And I also call the mean output size. Okay, yes. Well, we might as well just give it a try. So I'm going to do auto decrypt post static function OEAP decrypt and encryption algorithm, double my heart is 0 as a number um, and my pointer as a rabbit key in my first argument check um check state 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 uh, and I guess I need to entity output and I size the output. Okay. Oh, I need my ciphertext, which will be an array buffer. And so I have my and this cipher array buffer, which is my args into as output as array buffer. Let's return empty for now because I want to test this. Put a breakpoint here, and then basically just say there's a module. I'm going to set the property OEAP decrypt. OEAP decrypt. Move. Compile this. Make sure this started. And on my test. Then I have my output buffer, so I can say decrypted my private key could fail, and what I want to check, cipher array buffer, it's an object, perfect. So what I want to do is I want to copy the memory, and I'm going to say you state t cipher text is a new entity of size cipher array buffer and check the source code of OP-SQLite when we do non-copy. We get the array buffer data get. Here we're copying into okay. So we call this auto my ciphertext, which is a new int from the size, and we call the size the cipher length is cipher array buffer size here change to BIM change to this. No, I'm also using my other keyboard, which I don't use super often nowadays. It's this one. So let's get this. I try to get this done. Change to, and you're moving. Change to, perfect. Okay. Let's run this again. And I have my cipher array buffer, cipher text length, and my cipher text, which is empty. Good. Good. So now I can finally do just what's this. I can finally do the decryption, and that's going to be done with LC or EIP crypt, the encryption algorithm, the private key get private key my still need to copy the memory. Mem copy my destination is my ciphertext cipher parent buffer data and my ciphertext length. Now it's there, so now I can pass my ciphertext, my cipher length, my output, and it goes in here, my length and my cause arrow pointer. Good. Um, Is the type of this wrong? Oh, pointer, and this needs to be one side long, yeah? But this was working. Maybe as a reference. Do I need to dereference all of them? Probably. What's the error? Okay, in any case, so now we need to create a new array buffer and we'll return that array buffer. Or no, wait, it's not going to be an array buffer. Um, mm, mm, how do we get this? When we need to encrypt, have plain text. Mhm. I'm not sure what's the safe way to do this. So I'm just going to ask Pilot to do this for me. The output string. If we do this, maybe. Yet, if it compiles, well, it compiled. The test passed. Um, Hello world. So if we change this to quack, expected hello quack to be hello world. Oh my god, that works. Ah, okay, good. So RSA decryption is working. I don't want to bother with memory allocation just yet. Good. So that works. Um, okay, let's finish covering the API then. So we can encrypt, decrypt. What is this non-parameter actually? This could be interesting. Label. Um, what's the label? Blah 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 blah. Decryption. You know. Um, Hello. That doesn't think it must be identical to both efficient binding data measure operations. Uh-huh. The label operation configure. Yes. Yes. Please enter decryption or decryption. Does it also take a label when encrypting? Yes. Hmm. Maybe we should change that because that looks useful. So a big part of developing these libraries is coming up with a sensible API, let's call this, so that's not absolute nightmare to use. Did you try Nitro models? No, not yet. I'm planning on doing a video about the different module systems because it's confusing. Um, I do kind of understand Nitro modules. I think they're quite good for when you're using Swift and Kotlin. They make your life easier. But then again, I don't think a lot of libraries are written in Swift and Kotlin, except for the UI stuff. That there for sure. I think most UI libraries are just binding to the UI component. But for the type of libraries that I write, I don't think they're super useful. It's one more system that can fail, and I have already seen it fail. It also has some limitations, which are not very well documented, I think. So, um, yeah, that it needs its own video, Nitro modules. Um, Okay, let's play around with the types now while we're here, because otherwise I will get lazy at some point. So we need there is a, what is this? Uh, okay. To generate the private key, we need um, the RSA key size. And the RSA key size. Oh, can't see it from here. Well, I can see it from here. So my RSA key size, it's going to be RSA 248 0, and my RSA like that. I don't like this thing being out of order though. Oh no, they are in order. Not bad. Okay. And I need my port in RSA OEAP encryption algorithm. SHA-1 MGF. Why they repeat? Yeah, because it's repeated here, right? Well, in any case, 258, that works. Good. And I think that's all I need. So now I'm going to go back into my CPP file and my everything module contains a generate RSA private key. Then it takes key size. The public key generate private key. That's one, and then generate public key, and this will return. You return a RSA private key, which is of type. Don't return array buffer, you return RSA key, and this one RSA private key and returns a RSA key, also an object. Those are fine. These two are within a key module. Good. And then we have the OP encrypt. And here I'm going to change this to an object because that to me is a little bit better instead of 1,000 parameters that mean nothing. So I have my encryption algorithm, my public key, and my plain text. And this will return a array, right? Yeah, this returns an array. And decrypt, which is going to take algorithm, private key, my ciphertext. And on this one, I have a label, which will be string for you as well. Um, params labels. Mm. Why that must be, I don't know, it needs to be a string. Must be used when the same. My label red must be the same level. We're going to change this to um, this kind of shitty part about using the JSI. We'll call this sign. It's my args in zero as object, and here object get get property. I can't remember. Get property. Or we're on the encryption. Get property number. Good. Here, I'm going to get property public key. Apex. Plain text and use my args object as property label. Um, how do I need to pass the label? Okay, you know what? Let's forget about the label for now, because I can do that off screen and it's not super interesting for streaming. Um, um, not exist type generate. Let's see. What am I writing? Generate. Oh, private key crypt. And it's now going to be a object equal to this round width. And my algorithm is going to be an RSA encryption algorithm. This public key is going to be my and my platex. Nice. And here, do this. No. Visual 2 parentheses. Why are you doing this to me? One visual 2 parentheses around with, and here comes the algorithm, which is a RSA algorithm needs to match my private key and my I'm going to change this to cipher text here. That should work. I'm going to change this to the key size. First one. Okay. So here I need to do something similar. Copy this here. My algorithm. This is going to be private key, and this is going to be this. So now we can pilot, except that it doesn't work because I touched something. OAP encrypt. Oh, decrypt in here. Oh, I put it. Okay, well, fuck. I already changed that. Yank. And then paste. That works. Algorithm. Now, this is going to be privately. Fine. It's going to be the cipher. For now. Object is an object expected an array. Why expecting that? Why are you turning this into an array? That makes no sense. This is what I get for trusting Copilot. Julio, that works. So that means at some point we can add the label. I mean, it's there, but it's not used right now. But let's just test. Key size 248 and 256. Okay. Create variations of basic key size and update quickly. Yes. No. It'd be so stupid sometimes. Artificial intelligence is not intelligent. Let's see. Let's try this and sure. We just have a few variations of this just because, just to add some tests. Um, we will change this to, so this is tree size 2 and Sean 12. Size 2, Sean 3, 4, 3, 2, Sean. Okay, that should. That was weird. Hmm. You're loaded. Why are you loaded? You're not completing. Hmm. Oh, you are. You're just very slow. Ah, funny. Well, I guess some of these encryption algorithms can be quite slow. Maybe. Who knows? Good. Um, mm, maybe we should measure them, but I don't care. I just want the thing to work for now. Good. So we got that running. Um, to cover the API, we are still missing exporting because you don't want to keep that key. Private key there. Ref gives you the bytes. Right. We can put this in an array buffer, which then they can persist uh, however way they want. No mango, but on say extern C. There's a private key to bytes. Yeah. As left. Ah, well, that works. And one more function for the non angle. But on say extern key, there is a private key from bytes. From You- Let's change the name from here. There, PK, PKCS 8 from there, PKCS 8 bytes. I'm going to compile this for iOS. iOS. Good. And now we can create this for that. So my private key. This is Copilot because Copilot can help. Oh, no, what's in this thing that we just created? Um, there is a private key to where PKC byte. Huh? Huh? And then it dies because it doesn't know what to do. I'm going to say output. Oh, yeah. What's the size of this? Hmm. Yeah, this is problematic because this returns. Let's check here. It just returns a reference to a array of bytes, but we don't know how to reserve the memory on this side for that. Hmm. Hmm. I'll take a small break and be right back. Okay, so the problem we have now is that this bear thingy returns a slice or an array, which in Rust we know the size of, but in JavaScript we don't. So we don't know how to reserve the memory, which is a problem. Mm, what is the maximum size for a bear? Technically, there's a maximum integer there, but it's extraordinarily large. Maximum size. A PKCS 8 there for it here. Um, well, not ideal because we don't know how much memory to reserve. But I mean, what we can do is just reserve one memory or 1 megabyte. And if you have a key that's bigger than a megabyte, then, well, that is way too big. Mm, these are, yeah, reserve a 1 megabyte buffer because we do not know the size of before. Blah, 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 blah. Key, my output length, and then buffer, memory. Maybe I want to delete the output. Why not? Let's give it a try. And I want my there, yes, and now I want my there is a there KCS 8 bytes. Where is a private? So this takes blah blah. Kinda got it right, kinda, but not quite. Okay, so I take the data from my array buffer, and then I think I need the personal C. Let's say from where and my data, my length, and uh, where's this? Oh, mm, okay, so I'm going to do this like private handle. Like this, and like this as well. Then no, well, actually, that's better. I like that better. Or no, that's not correct. And then I want my private key. So then my private key, I'm going to add a constructor for the private key that takes that. Here my new constructor, one that just takes the pointer and initializes it. Yeah, that will work. So let's write this for that. It can encrypt and decrypt our private key to their ECS. Um, before that, we need to add the message here. Private key. Um, Let's call this the other way around. I compile this, and then finally here we can say, okay, comes my private key generated, and I can say private key bytes, my private key from bytes. This is not going to match, but later this should still work, right? Um, there is a error getting on. And here again, hope I did stupid things because it doesn't understand. Um, because it doesn't understand macros, it doesn't matter. There it is. And now we compile it. Oh, it's on the key. So this will they come here, here, here. Um, again, it's wrong, very slow. I don't know why. Awesome. Um, private key. Yep, that works. Good. And we can finally do the same for public key. No mango, but on say external C, Or the public key will be their encoded X. I say public key to their X bytes. That works. And Bob on save. Let's see from um, from Git OS, and we can then finally go to put this in the middle of something. Auto and say public to their X bytes post function public key. Yes. Yes. Mm. Um, Here, one thing we need to take care of is it bytes. We will do the bytes as ref. One thing we need to take care of is we say if is bigger than this. No, no, really. Unit. We okay. Mhm. We need to do the same here. There. Mhm. Hmm. It's not going to work in this case. No. Um, oh, fine. But it's something I never tried. How do you do this? Command Shift. In C++ when I create constructors that don't have anything in the class. Okay, here's a public key from the raw pointer. Hmm. Hmm. Raw raw pointer. C++ happy with this? um, empty constructor. Yes. Okay, that compiles. Bytes. Public key. Um, make shared. Mm. Okay. Um, okay. Fruits. Still make shared, but um, this seems okay. So, um, it's can for for and public key to X. Well, bytes, 1 bytes. And out non-static without an object argument. Oh, how do you create static methods like this? No. It. Um, I got it. How do you how do you which one? And it crashed. And it crashed on who knows where it crashed. Debugging these errors. RCT. Who knows? Something. Um, uh, this and this. Mhm. Oh, I did my No, I didn't. Doesn't matter. So this is not going to work. What I want is that the encryption works. And here and bytes. I'm going to tell it here. This one. Crash out. Uh-huh. Hmm. Okay. I don't know why it crashed before. Doesn't really matter. If it cannot be reproduced, it does not exist. Good. So, I mean, there's still a few issues to take care of, but working encryption. Work, there is a encryption, encryption, and import, export of keys, which is what we want. And I'm going to go ahead and readme and RSA section. Say, yes, or RSA. What else do we have in here? RSA key size, RSA O, encryption algorithm, um, OP engineer C. I'm just going to take this example. Um, import, export, good. It's all 9 minutes. So if we now go to OP-AWS, see, app support, pull requests. Good. I'm going to cut the stream there. Um, it's really interesting because it touches Rust and C++,